So let's get this built. Hey everyone, and welcome to another episode of James Dean Designs. If you're new to the channel and love CNC, make sure you hit that subscribe button somewhere in the corner that I can't currently see. Now in today's episode we are going to be unboxing and building the FoxAlien Vasto, which is their latest CNC machine to the market at the time of recording this. And that opening clip was no exaggeration. This comes in 3 large boxes, 2 in front of me, 1 down at the side of me. Now normally I would do a review and build video together, but for the purpose of this we are just going to do the build in this video, and when the review is ready there'll be a link up in the corner for you to see everything that this machine is capable of, because to be honest the specs of it are looking absolutely brilliant. So let's get this unboxed, dive in and start to get it built. Now it may sound obvious, I'm starting with box 1, and one of the reasons there are 3 boxes because as you can see everything is so well packaged with plenty of protection around it, because these do travel a lot of distance. So let's get all this unboxed into some sort of order and then we'll begin the build. So that is everything out of the box, and already I'm impressed with a few little minor things, such as the fact they give you 3 separate spindle mounts, not only for the spindle that comes in the kit but also for the Makita and DeWalt routers at 65mm and 69mm respectively. I should also mention, don't worry if you don't see the instruction booklet in the first box, it's actually in the second box. I was slightly confused but I found it in the end. Now some of the components are particularly heavy, so do be careful and get someone to give you a lift taking them out of the box if you are struggling. One of the reasons they're so heavy is because they largely come pre-assembled, which obviously makes our life much easier when getting all of this built. Just to put it into perspective, the entire contents is around 45 kilograms, so there is a bit of weight in it. So yeah, do be careful when unpackaging it. But let's move on and get all this assembled. So we are literally just about to get started, but there are 3 quick things I wanted to mention before we touch a single bolt. The first one is actually go around and check the bolts on all the pre-assembled components and do make sure they are tight. It may seem a waste of time, but it's better to be safe than sorry, especially if it's a bolt that will be hard to access later on after assembly. The second thing is, for the most part, we are going to be following the instructions page for page. If I find a section that I think can be done better, I will point out that I'm not quite following the exact instructions at that point. The third, and possibly the most important, is Loctite, particularly blue Loctite. If you're not familiar with this, it is like a soft glue. You apply a drop to every bolt and it just helps hold everything in place. Now you won't see me use it during the video just in case I have to take anything apart to reshoot a particular clip, but it is definitely something that you should consider using when assembling your machine. So we begin with the 2 y-axis, and for clarity these plates are the front, the stepper motors are at the back of the machine, and we're going to install the 2 dust baffles on either side here. Now there is a difference between the dust baffles. One has 2 gaps in it. This goes on the side with the limit switches and the gaps go over the limit switches themselves. We'll be installing them with M5 14mm button headed Allen bolts. Next we'll be installing the X-axis profile. There are 2 bolts on either side on the front, but only 1 bolt on either side on the back. The bolts being used are M5 20mm bolts with a flat washer and a spring washer. The spring washer goes on first, followed by the flat washer. Now get every bolt in place first before tightening everything up. I suggest installing the support at the front first because it will help to pull everything in when you come to do the back one and just keep everything quite square. Now the outside of the y-axis are quite heavy and it will have a tendency to pull them out. So as you go around tightening things up, use a square to check that the end plates are coming out as parallel as possible. Now I don't know if the camera picks that up, there is a slight gap there, so I will need to readjust that one. Also go around checking the inside of the frame, making sure that also remains square. That is looking pretty good. If you are in any doubt how to check this, say you can use a set square or a combination square like this. You can also use the tape measure, go diagonally between corners, do the opposite direction, and you should have the same measurements. If you have different measurements, it means something is out or skewed. Loosen the bolts off, readjust accordingly, keep checking the square and pinch them back up. Next, we're going to bolt these 2 supports in from the outside of the frame using the M5 30mm bolts. Again, preload them with a spring washer and a flat washer. When you go around doing this, what I would suggest doing is doing one bolt in each opposite corner and working round. As you put every bolt in, again, keep an eye on how square the frame is and make sure it all stays as square as possible. If when installing those side bolts you are struggling to find the hole, no dirty jokes please, slacken the bolts off on the front or back plates to give you a little bit of wiggle room, and that will allow you to get the bolts in much easier. Just obviously once you come back to tighten them up, check squareness again. Now we're going to move on and install the spoil board. All of these pieces are exactly the same, so it doesn't matter what is front to back, back to front. There is a little bit of play left to right, so what I would say is start one side and work across. We're going to be using the M5 16mm bolts to install these. We're going to start one side, work our way across, and just make sure everything aligns up with the holes. Next we're going to install the X-axis gantry, and I've spun the machine around 90 degrees to make it easier for you to see. Now before you pick this up and go to drop it on, what I would suggest doing is measuring the distance of the Y carriage from either the front or the back plate and doing that on both sides to ensure they are parallel. This will just make it easier when you're dropping the gantry on top, because there is a bit of weight in this and you don't want them being out of alignment. We're also going to be using the rest of the M5 16mm bolts to hold this in place. Now the carriages are pre-cut, so this should just drop straight in and hold itself in position nice and easy. So I actually found there was about 0.5 millimeter difference between these two. Now it doesn't sound much, but because this is such a solid machine, it's quite difficult to then pull that in to allow the gantry to drop on. So what I have just done is used a quick clamp to pull that in a fraction. If you are struggling to do it, maybe get someone to give you a hand and just put a bit of pressure on those side plates in order to get it to drop in. And then it should just drop in nice and easily, and we'll slide that into place. Next we're going to install the Z assembly with some M5 16mm flat cap bolts. Now there is a little bit of weight in this, so do be careful when you're doing it. I suggest putting one bolt through the hole, getting that in, make sure it's in a good few turns to hold it, and then quickly grab another one and slot that into position and just try and get that into the hole in order to take the weight of the Z assembly. With two in place, you can then move around, do all four, and finally tighten everything up correctly. Once all four are in, bring your square back in and just place it against the faceplate and just make sure everything is perpendicular to the bed and that it's nice and square. Now technically the bed hasn't been trammed in, so this is not necessarily going to be 100% perfect, but the more square we can keep it, the better it will be for when we come to tram the spindle later on. Fix the limit switch bracket in with the M3 8mm bolts. These just go straight in, should self-center, and tighten them up. In today's build we're using the standard spindle holder. This is the smallest of the three. There are multiple holes for it to go in. We're going to be focusing on the bottom four to install this using the M5 55mm bolts. So we're going to place them through. We're going to start with the two on the left hand side first. Again, just get a couple of threads in there, insert another one, make sure everything is remaining lined up, and we'll just pinch those up a little bit. Now we want to get them quite tight, but we still want to have a little bit of play. And we're going to put the other two in for the time being, slot those in. Now again, we want to pinch these up, but not till the point where they're starting to bite the actual clamp itself, because we'll struggle to get the spindle in. So we're going to get them in a few turns, make sure it just takes some of the wobble out of the spindle holder, and then we'll move on and drop the spindle in next. Just before we drop the spindle in, bring your square back in and place it against the spindle holder. Make sure this is perfectly square and perpendicular to the bed. Once you're happy with the position, then just tighten those back up to hold them in place. You only want to tighten the two on the left for the time being. We can then move that out of the way and we'll drop the spindle in. We want to roughly drop this in about halfway and pinch up the two remaining bolts so it just starts to hold that, and tighten that one up a little bit as well. You may need to do this with the other side of the Allen bolts. Make sure you get enough pressure on them. Tighten one up at a time, half a turn or quarter of a turn, and keep going back and forth between the two until it's ready and nice and tight. Next we install the first of the X-axis drag chain brackets. Now this will fix into two T-nuts that are already in the extrusion. Space them out so they are roughly in line with the holes of the drag chain bracket. We're then going to use some M5 6mm bolts to hold this in place. As usual, just get one in place first and then move on to the second one. Because obviously these T-bolts can move about a bit, it's easier just to do the one, reposition the next one and then tighten that up. The second part of the X drag chain bracket fits directly to the back of the Z assembly using the same M5 6mm bolts. Next is the smaller of the Y drag chain brackets, and this fits directly to the left hand side of the Y axis in the two pre-tapped holes. We'll put these in using M5 6mm bolts, the same as the other bracket. These just go straight in and hold the bracket in place. Next is the second of the Y drag chain brackets. Now these are fitted with the same M5 6mm bolts but onto hammerhead T-nuts. Now put these on first, keep them parallel, and it makes it much easier just to put them into the extrusion, give it a bit of a wiggle, and then you can easily tighten them up in place. So at this point I'm going to deviate away from the official instructions. They tell you to start by installing the drag chain and cabling on the Y axis. I'm going to start on the X axis, and there is a reason for this. The cabling itself can move up and down within the drag chain, so you need to ensure you have enough cable left to connect everything up. So it's better to start at this end, make sure you have enough to connect your spindle, Z assembly, all of that, then work backwards and connect the rest of the drag chain. It just means you don't have to shuffle anything about later. So we're going to fix the first part of the drag chain down with some M4 6mm bolts. Now these have very fine thread, do not over tighten them. So with those two bolts installed, now make sure you have enough length on the cable to connect everything up. You don't have to connect everything at this stage, but you may as well. Also with the spindle cable, remember this has to go up and down, so make sure there is definitely enough play to accommodate that. That is roughly about how much I've got sticking out of this, and that should cover it. So I'm now going to move on, put the remaining bolts in on the opposite end of the drag chain. Lay your Y drag chain in place, and again make sure you have enough left on the cables to connect everything up without there being too much tension. Shuffle everything back and forth as needed until it sits comfortably. It is quite tight to get this bolt in, but you should just be able to see it from the top. Slide it down, drop it in, and then tighten it up. And then the last two bolts for the Y axis drag chain. If you haven't done so already, go around and connect all the cables. Not only are they colour coded, but they are also labelled to match. The connectors themselves will only go in one way, so make sure you align them correctly, push them in and you should hear the click. And the same for the motor cables as well, they will only go in one way, push them in and they should also click. With the Y2 stepper motor cable, you can either use a cable tidy, fix them to the extrusion and put the cable in, or simply tuck it into the extrusion, push it all in and it should hold itself in place. And with the spindle, whilst it may seem obvious, negative goes to negative, positive goes to positive. Push these on, make sure they are secure and that the cover is then covering the terminal itself. Do that for both sides. Now there is a cable tidy provided in the kit. This can allow you to attach the cable to the top of the Z assembly, and it just stops all of this moving about, but obviously still allows the cable to come up and down when the Z assembly is moving. We've brought the control box in now to finish the physical setup of the machine, but before we start connecting anything, the voltage switch for this is on the underneath of the control box. By default it will be delivered switched at 110. If your country does not operate at that, like I'm in the UK, that's 220 volts, make sure you switch it over. This is very important. If your country runs at a higher voltage than 110 and you do not switch it over, you may burn out the control box, so make sure you have that on the correct setting. Now with that done, we'll lay this down flat and get all of these connected. Again, they are all labelled up to match the labels on the control box, so let's work around and get them all installed. The wire for the Y-axis limit switch sticks out in a slightly awkward place in relation to the linear rail. Make sure to tuck it away underneath the dust guard. Check your emergency stop button before starting anything. If it is pressed down, release it by turning it and it will pop back up. Other than plugging in the power cord and the USB cable, the physical setup of your machine is now complete. So now at your PC or laptop, make sure you connect the USB pen provided with the machine. Also make sure your USB cable is connected as well. First thing we're going to do is go into the USB drive that was provided. We're going to continue through Vasto 4040 and Vasto 4040 again. We have options for Mac or Windows. We will be continuing with Windows for this tutorial. And we have 3 folders. The first thing we need to do is go into the software folder. We then need to install the driver. The driver is what allows your PC or laptop to talk to the CNC machine itself. So we'll go into this folder. This is the driver. Now as I open this up, I will be prompted with a security message that the screen recorder software doesn't capture. Don't worry about it, just click yes and move on to the next screen. Then you'll be presented with the installation window. Click install. This will take a second to install, but when it is done, you will be prompted to say everything has been completed. There we are, driver install a success. So we'll click OK, we'll close this down. And to test that that has installed successfully, what we'll do is come down to the Windows menu, type Device Manager, and open the Device Manager control panel. From here, we can head down to the ports menu, expand that out, and we can see something similar to what we just installed, CH340. If I drag that down, CH340. Now what we need to pay attention to is the COM number next to this. Mine has installed on COM6, so I'll make a note of that because we'll need that number shortly. Your number may be different. So we'll close that down and we'll come back up 1 level on the folders. We'll now move on to the controller software. This allows us to jog the machine about, run files and do some basic testing. It gives us 2 options, GRBL control, commonly known as Candle, and UGS platform. Me personally, I prefer UGS platform. It has additional functions that Candle does not. However, Candle is sometimes easier for beginners to get going with, so we're going to start with that. We'll go into the Candle folder. You'll see a lot of files. The one we're interested in is the GRBL control candle.exe file. So we'll double click and open that up. As a very brief overview of Candle, the big rectangle that you see at the top is the visualizer. When we load a file in shortly, this is where it will give you a 3D simulation of what it may look like. The bottom rectangle is where you will see the commands being sent back and forth to the machine. On the right hand side we have coordinates for jogging things about, some basic control functions such as running the homing sequence, setting the 0 and unlocking and resetting the machine. We then have a spindle control where we can turn the spindle on manually and control the speed up and down. We have jog functions to be able to move the machine about forwards, backwards, left and right, and then control the Z axis on the right hand side. The step is how far you expect it to travel every time you click one of these buttons, and this is measured in millimeters. So 5 steps will be 5 millimeters. If you click right, it will travel right 5 millimeters at a speed of 1000 millimeters per minute. Both of these are variable and can be changed depending on how fast or how long or short distances you want to go. Down in the console area, this gives you the option to see the G code itself and enter some if you want to. We'll move on to this shortly. Now the first thing we need to do is to get Candle to connect to our machine. You only have to do this once, and every time you open Candle up after this it will connect automatically. But to begin with we need to go up to Service, come down to Settings, and we'll see this connection option here on the right hand side. Now I made a note earlier that my COM port was number 6, so I'm going to click on this, click number 6, and if you don't see the COM number you're after, click the refresh and it should load it in. Your baud rate needs to be 115200. If it shows any other value, override it and type in this baud number to make it connect. There are some additional functions in here where you can input the maximum, minimum spindle speeds and travel speeds, and also the Z probe command. We'll move on to the Z probe a little later in this video, but for now we're going to click OK and everything should connect. Now what we can see down in the bottom right hand corner in the console area is we have a little bit of code popped up and we have this error 9 message. Don't be alarmed by this. Every time you turn your machine on or connect it, you will get this message. Because the machine has limit switches, it is just a safety feature. All you simply need to do is come up to the unlock button, click that, and the red message goes away and your machine is then free to use. If you have not done so already, at this point turn your machine on. At this point, your machine is now connected to your PC, and we'll run some very basic tests just to make sure everything is moving as expected. We're going to come down to the step option. I'm going to take this up to 40, so we'll move 40 millimeters every time we click a button. And I'm just simply going to work around all axes and make sure they move in the directions that they are expected to. So we'll go forward, back, left, right, up on the Z-axis, and down on the Z-axis. So everything is moving as it should be. If for any reason your directions are not moving accordingly, you can come down to the console area. I will just expand this a little bit to make it clearer. Click the box at the bottom, type $, hit enter, and it will give you a list of your GRBL settings. If your axes are not moving the correct way, you may need to change your $3 setting. For this though, the default should be 0, as we can see there. One thing I will point out in the GRBL settings for more advanced users is soft limits for this machine is turned off. If you want to put them on, you can change this from 0 to 1. The other thing I will also point out is the soft limits on this are probably set a bit conservative. So 130, which is your x-axis on here, is set to 400. If you want to increase this, I got mine to about 422. On the y-axis, which is 131, I got this to about 436, and on 132, which is the z-axis, I got this to about 105. So if you do decide to use soft limits, make sure you measure yours, because you can increase these and get a little bit more out of your machine. But generally speaking, you shouldn't need to adjust any of the GRBL settings because they all look pretty good, and so we're good to go and get a first test file done. So I've clamped a scrap piece of MDF down to the bed. I try and keep the clamps away as far as possible. You can use blue tape and CA glue as an alternative method to doing this, and it avoids using any clamps at all. Next we're going to install a 30-degree V-bit. These came with the kit, and you just take the blue cover off and you will see they are quite sharp, so I leave that on whilst I'm installing it just to avoid injuring myself. Underneath the ER11 collet there is a hole. Slide this up into the hole, and it should go in there quite well, and then bring your spanners in and begin to tighten this up and pinch it up. Make sure it's nice and tight. Once you've done that, you can then take the protective cover off and we're good to go and get our first engraving done. Connect your Z probe to the back of the machine. You then ideally need a pair of calipers to measure the thickness of the Z probe plate itself. You can use other methods, but these will be the most accurate and easy. We can just about see that is reading 15.1 millimeters. So I'm going to quickly jog the bit over and make sure it is sitting somewhere near the middle of the material. I'm then going to place the Z probe underneath and connect the alligator clip to the bit itself. We then come up to service, go to settings again, and we'll come down to this probe command. Now don't be put off what all this actually means. If you want to try and understand it, it means it's going to try and travel 50 millimeters at a speed of 100 millimeters per minute to find the Z probe itself. And the measurement it knows the Z probe needs to be at is 15. Now we just measured this and mine's actually 15.1. So I'm going to update this measurement and put 15.1. Obviously if yours is a different measurement, then you will need to adjust that full figure depending on what your measurement actually is. We're then going to click OK. Now that has set the thickness of the Z probe, so we're then going to come up to the Z probe function and click on it and let the Z probe run. That has now set the depth of the Z probe, which means that when we take it out the way and go to start our job, it should know exactly where the top of the material is. I'm just going to move this slightly towards the bottom edge of the material and over to the left. And I'm then going to click the reset the XY position, and this zeroes everything. We've already done the Z using the probe, but if you do a different method such as the paper method, you can use the 0 tool here to lock in that one as well. Now we're going to load a quick test file in. We'll come up to File, Open. We're going to navigate through to that USB drive. It's already taken us to the software folder, so we'll go up 2 levels, and then we'll come down to test code, and we're just going to load in the FoxAlien option. Now, as I mentioned earlier, this is your 3D visualization. This little icon in the bottom left hand corner is the start point or your origin for the job, the 0 position that we have just set. And the dotted lines are the path it's going to take between each letter or each carving. It will then do that shape, move to the next one, so on and all the way through until it has completed everything. If you come down to the bottom area here, you can see some numbers, 118, 41 and 4.3. These are the X, Y and Z measurements that it is going to move once we start the job. So from this start position to the far right hand side of it is 118 millimeters. From the start position to the top of the F it is 41 millimeters, and the depth from the start that it will travel, including the safety height that it raises up and goes back down, will be 4.31 millimeters. One quick test I forgot to do earlier, which we will do now, is fire up the spindle first to make sure everything is running. So this cog over here should start the spindle up. And we'll click it again to turn it off. So we know everything is running as expected. We also know we've set the 0 position for this to start using the Z probe and then the 0 button up here. So all that's left for us to do is to send this job over to the machine and get it started. So that is the FoxAlien Vasto built, checked, and we've done our first test cut. Everything has worked straight out of the box as we've come to expect from FoxAlien products. Now, I haven't spoken about the spec of this during the video because, as I said at the start, I'm going to cover that separately in a review video. Make sure notifications are turned on for the channel and you'll get the notification as soon as the video goes live. But first impressions, wow, what a machine. There are so many little things that they've thought of in this that you probably don't even realise that just make it such a superior build and machine. And I'm really looking forward to doing some more advanced testing with this. I've got a few days off coming up, so hopefully, well, more than likely, most of that time is going to be spent in here playing with this machine and doing some more testing. Here is a quick one that I did off camera earlier just to show you some things that it is capable of, but we'll be doing much more testing with this as soon as I've got the time and get the review video done. If you are thinking of buying one of these, please check out the affiliate links in the description area below. As always, they do not cost you any extra. I may just get a tiny back in commission that helps keep the channel going and producing these videos for you. That is everything for today. Thank you very much for watching. Final thanks always goes to my patrons. I'll see you all on the next video.